Go.
Today we're going to be talking about integral as the area under the curve. Integral as area under the curve can basically be defined as finding the area between 2 points, which can be found by using the integral. You break the 2 points up into shapes which can be found the area of. So, for example, you have squares, triangles, circles, and trapezoids, which all can be used to find area through certain functions. So I have drawn this graph here, and we have a series of functions all combined to make one big graph that can be broken up. So first we're going to start off by finding the integral of 0 to 3. Now, if we look at the graph, from 0 to 3 is where we're finding our integral from. And we have two different shapes. So I can break this up into a rectangle and a triangle. So the area of a rectangle is length times width, which is 3 times 2, which equals 6. And then we have the area of a triangle, which will be 1 times 1 divided by 2, which is a half. So once I add the areas of these two different shapes, I get 6 plus 1.5, which gives me 7.5. Pause. Now that we see that finding the integral of 2 points is very simple, but let's try it a different way. What if our A to B is backwards? So instead of having from a smaller number to a larger number, we have a larger number from a smaller number. So on the graph, we're looking for the area on the curve from 8 to 6. So we would go about finding this problem in the same manner that we did find a regular integral. But the only difference is we're going to negate the final answer. So I'm breaking this graph up into similar shapes that I can find the area of. So I have two triangles and a square. So the area of the square, once again, length times width, which gives me 1 times 1, which is 1. I have a triangle with 1 times 1 divided by 2, which is a half. And I have another triangle, which is 1, 2, 3 times 1 divided by 2, which is 3 over 2. Now I have to add all of these together. So I have the area of my rectangle, which is 1, plus the area of my first triangle, which is 1/2. Then I have the area of my second triangle, which is 3 over 2. So to make this more simpler for me to add, I will change this into a fraction to make it all have common denominators. So I know that it's over 2, and then 2 plus 1 is 3, and 3 plus 3 is 6. And once I simplify it, I get 3. So the answer to the integral from 8 to 6 is 3. And now that it is backwards, we must negate it. So our answer would be -3 instead of +3.